Hi, this is Charlotte Rodeen-Dickert, and this is a brief tutorial on the analog to digital conversion process in audio recording. So let's begin by discussing the difference between analog and digital. An analog signal is a continuous signal that varies as a function of time, and we can convey information with this signal by varying either the strength or the frequency of the signal. On the other hand, in digital, it's a series of many little bits of information. And the information is conveyed in terms of two states, binary. So we can have either positive or non-positive, 1 or 0. It's kind of an all or nothing. So a bit is each one of these digits, 0 or 1. And a byte is a string of these bits that are addressed together as a group, usually an 8-bit byte, such as this here. So there are two important steps in analog to digital conversion. There's more to it than this, but these are the two important things that are happening. The first is sampling, and that is the process of taking a snapshot of a wave at a particular frequency. Okay? The next important step is quantization, which is where we have to assign a numerical value to the signal level at that point that the snapshot was taken. This then gets coded as a binary number, and the precision with which we can do that depends on the bit depth, as we'll see in a moment. So if you start with a wave such as this, as would be produced if you plucked a guitar string, and you took samples at a series of intervals, like this, take a sample here, take a sample at the next one, and all along, we're going to see where the wave is at each one of these intervals. Okay? Now we need to quantize this, and we start by determining the range of the signal and then dividing that in half. So we have two parts. Remember the binary. So this is 1 and 0, above or below. That's the first thing we're going to find out. Then we divide each of these into two parts. So for each of these we have 1, 0, above, below, and then again. So here for each of these smaller intervals we have above, below, 1, 0. And the same thing down here. Okay? So for example, if we look at this point here, okay, it is in the upper part of this range. Okay? So that's going to be a 1. And then it's in the bottom part of this range here. So that's going to be a 0. And then it's in the bottom part of this range here. It's below the yellow. So that's going to be a 0. So another example. Looking at this point, this one is below for the first round. Then it's above in this part, so that's a 1. But then it's below here, so it's going to be 0, 1, 0. Now in the real world, this would continue on, but for our example, we're just going to do 3 for the sake of clarity. So what's happening here is you have this voltage as a function of time that's being converted into a binary code that the computer can read. So let's take a close look at this. If you're looking at this process here, okay, and you're taking samples along here, the more samples you take, the more information you have. So the higher the frequency, the more samples, and kind of the smaller the intervals on the grid this way. And going this way, the more divisions that you have, the more you keep dividing this by half, by half, by half, means the closer you can pinpoint exactly where these values are. So that's the more divisions you have, the more bit depth you have. Put these together, and that gives you truer sound reproduction. And right now the industry standards that you may hear are 48 kilohertz for the frequency and 24-bit for the bit depth. So what does this come down to in recording? Well, analog signals are continuous, so it's going to include all the noise. On the other hand, digital, the computer only understands 0 and 1, so it's going to eliminate extra noise, resulting in kind of a crisper sound. In analog recording, it's a linear format. You have to wind and unwind to get where you want to be. On the other hand, in digital, it allows random access to any point that's on the recording, so you can get right where you need to be, right when you need to be there. Also, tape can be very expensive, take up a lot of space, be difficult to store, needs to be stored under proper conditions, otherwise you lose it. Whereas digital recording, it's not going to degrade over time, it can be compressed, it's a lot easier to store. So what this really comes down to is the quality of the sound. Analog has a warmer, more natural sound quality. If you listen to LP records, has that sort of tone to it. Whereas digital recording on a compact disc is going to be sharper and clearer, but sometimes it sounds a little bit more mechanical. So it really just comes down to your personal preference. So I hope this explained a little bit about the analog to digital conversion process, and thank you very much.